So I start my class. Okay. So today we'll learn about the one of the important popular algorithm, whatever nowadays we are using. Okay. The name is called Advanced Encryption Standard AES algorithm. Okay. Next we discuss about the primality test. So today we'll learn about the Advanced Encryption Standard AES. Actually, in the AES algorithm, we take it in the two part. One part is a evaluation criteria part. That means AES introduction and history of AES, and what are the parameter is used for your criteria evaluations. Okay, this is one part. Another one part is here AES cipher. AES cipher means how the encryption and the decryption algorithm is performed. Okay. That means in university examination, the question will be asking in the two part. One part is a AES criteria evaluation. Another one part is a AES cipher. So depending upon the question asking, you can write as per correct answer. Okay. Okay. So now we can start the AES introduction. So normally, the advanced encryption standard is a more popular and widely adopted symmetric encryption algorithm. So you can clearly listen all the points. Okay. So AES is a symmetric encryption algorithm. Okay. Previously, you know it very well. Already we discussed one or two algorithm. What is DES algorithm? One algorithm, DES algorithm. It can be used as 64-bit input and 56-bit key. Similarly, to overcome some problem, we use the double DS and triple DS, especially in triple DS with 3 keys or adapted by the applications before developing this particular AES. Okay, so normally a replacement for DES was needed as its key size was too small, because DES only the 56-bit key. Then only the developer will be planned for to developing AES algorithm. Okay, the researchers can develop the AES algorithm. So with the increasing computing power, it was considerable vulnerable against the exhaustive key search attack. That means brute force attack. So another one thing, the triple DS was designed to overcome this drawback. Okay, whatever DS can have some problem, it was overcome by the triple DS. But what happens in the triple DS means it is a very slow computing. Okay, the computation is very slow. So that's one problem of triple DS. So overcome all those things, we can go for the next level of algorithm that is called as a AES. Apart from that, it is also found at least 6 times faster than the triple DS. Okay, AES is 6 times faster than the triple DS. So the AES is a block cipher intended to replace DES for commercial application. It uses 128-bit block size. AES used 128-bit block size, and key size is a 128 or 192 or 256. It depends on the how many number of round we can using in the algorithm, AES algorithm. Okay, this is our simple definition of AES. AES is a block cipher intended to replace the DES for commercial application. It uses the 128-bit block size, and the key size is a 128, 192, 256. All the 128 means 10 round, and then 192, 14 round, and then 12 round, 14 round, respective manner. Okay. So first, we take the first part of the AES algorithm. First part of the AES algorithm is called evaluation criteria for AES. So here we contain the origin of AES, AES requirement, and evaluation criteria for AES. Okay. First we discuss the origin of AES. So actually in 1997, NIST, what is the NIST? National Institute of standards and technology. It's based on the US organization. Okay, so in 1997, NIST began the process of choosing replacement for DES, because you know it very well, in the year of 1997, actually the DES will be breakable one. The attacker can attack that particular DES algorithm to get the plain text without knowing the knowledge of key. Okay, so that's why we need some replacement. So that is called as a advanced encryption standard. Okay, so initially the US NIST issued a call for the cipher in the year of 1997. So totally 21 proposal come to the NIST. In this 21 proposal, 15 proposal or 15 candidate accepted in the June 1998. From the 15, again 5 were shortlisted in the August 1999. So in this 5, the proposed model AES is done by the Reginidol cipher. Okay, so in the year of 2000, Reginidol is nothing but the two author surname, Ridgman and the Damon. Okay, so the Reginidol cipher was selected as a, that means the AES algorithm is selected or accepted or adopted by the NIST. Then it was used for the applications. Okay, this is what the origin of AES. Next one, AES requirement. So requirement means one thing is a plain text. That means what message you want to be sent. It is a block cipher. So block by block you can send it. So what is the block size or input size? It is a 128-bit. You know it very well. DES algorithm take the 64-bit input block. Here we can take the block length of 128-bit, as well as the key length also 128-bit. We can also varying of key length here used depending upon the rounds. Suppose the turn round we are using 128-bit key length we are using. 12 rounds it will be take 192-bit. 14 rounds means we take the 256-bit key is used for the encryption algorithm. Okay, another one thing, it is a iterative cipher. Normally DES is a feastal cipher, but AES is a iterated cipher. Okay, this is a the requirement of AES. Next one, the evaluation criteria of AES. So at the time of announcing the proposal of a cipher of AES, normally the minimum criteria or the basic criteria is announced by the NIST, the month of September 12, 1997. Okay, so it can be categorized in the 3 important types. So what is here? Security, another one is a cost, another one is a algorithm and implementation characteristics. So security normally depends on the following parameters. For example, what is the actual security? Normally security means it depends upon the key size. So the minimum key size here we can using the 128-bit. So it was very, it developed the algorithm is very complex. So the security level is very high. Okay. So another one is a randomness in the input block. So randomness the input block, then soundness in mathematics basic. So what is strong mathematics we can use it for both encryption and decryption or in that particular AES algorithm. So all are factors in the security manner. Okay. Next one is your cost. Normally the cost depend on the following parameters. For example, the licensing requirement. Licensing requirement normally the royalty will be fully free. So anyone can use the particular algorithm. That way, this criteria is requirement is given to the developers or researchers to develop his own algorithm. Okay. So next one is a computational effect is very important part. Another is a memory requirement. What is the code size? What is the algorithm code size? What is the RAM requirement for the software implementation? Because this particular AES algorithm is used in the smart card ATM also. Okay. So the memory requirement also one of the parameter consideration in the cost aspect. Third one is here algorithm and the implementation characteristics. So the algorithm may be flexible one. Flexible one means the modification can easily adopted. because the key size will be varying, so the modification can easily adapted. So algorithm can accommodate additional key and the block size. So normally algorithm can be implemented on variety of platform and application, for example ATM and broadcast ISDN and voice and satellite communication. All are that particular algorithm, security algorithm is used in all the applications. So next one is the algorithm can implement in their stream cipher or MAC generator or pseudo generator and as functions. So the hardware and the software suitability and the simplicity. The design of algorithm is very simple one. These are the major criteria requirement is given by the NIST. Okay, all are satisfied by the Reginald method. Okay. So next one, this is the final criteria of AES algorithm. That means it can be general security. It satisfies the easy of hardware and software implementation, then restricted space environment, attacks on implementation, encryption versus decryption, the key agility, flexibility, potential for instruction level parallelism. Actually, parallelism concept you can use it in the computational efficiency. Here you can using the parallelism concept also, but in the DES algorithm not possible. Okay, so these are the final criteria of AES algorithm announced by the NIST, because these are all satisfied, then only that particular purpose only accepted by the NIST. So the original method, that means whatever now currently we are seeing the AES algorithm is accepted by the NIST. Okay, that means that particular AES algorithm satisfy all the criteria requirements. Okay, this is what you are the first part. Now coming to the second part. The second part, we briefly discuss about the AES cipher and the encryption and the decryption operation. What are the steps are followed in the operations? Okay. So the originator proposed the AES defined a cipher in which block length and a key length can be independently specified. That means the key block length it will be 128 bit, but key length depending upon the rounds. 10 rounds means 128. Okay, then 192 or 256 bit. Okay. Now, then normally it is a iterative process rather than Feistel. Feistel cipher is used in the DES algorithm, but here we can't use it. Here you can use it the iterative process. So normally the process of data means input block 128 block, then key block on another 128 block. Okay. So number of rounds the 10 rounds. It is the initial level. Okay. So the process a data block, how we can represent a data structure in the AES cipher. Very interesting thing, this one, comparing with the DS. Okay. So 4 column of 4 byte. Normally we can take it here. The column wise only to do some performance in the operation in the AES. Okay. So the process of data as a block of 4 column 4 byte. Okay. As well as it operate on entire block in every round. That means the entire block in every round. Okay. Just so you know this information. Okay. The next one, what are the characteristics of AES? So normally it resistance against the known attack. So you know very well, known attack means sometimes the plain text or cipher text will be known by the attacker. So getting that particular small size of plain text or cipher text, you try to gain the keys or plain text. So it was resisted by this particular AES algorithm. Another one thing is a speed and code compactness on many CPUs. The speed, because it's a parallelism concept here, you can use it. The speed and code compactness is possible. Another one is a design simplicity. Okay, this is here the main characteristics of AES. So you read out all these steps of operation carefully, then only you can easily understand what is the operation of AES. Okay, AES is an iterative cipher. It is not a Feistel cipher, it is an iterative cipher. It is based on the substitution permutation network. So the iterative cipher you can also call as another SP network. Okay, substitution or permutation network. So AES perform all its computation on bytes. Next point, in the operation of AES, it perform only by the byte to byte. Okay. So AES data treat 128 bit of plain block or plain text block as a 16 byte, because 128 into each and every byte. 1 byte is equal to 8 bits. You know it very well. So normally 128 bit block we can take it as a input. புரியுதா? 128 bit தான் என்ன பண்ண போறோம்? Plain text input block we take it for your encryption. So how we can represent in the algorithm? It can be represented in the 16 bytes. Okay, not bit in the version of bytes. So 16 byte, how we can arrange how we can represent that particular all the 16 byte means it is in the form of matrix. Matrix means rows and column. Okay, this is a example of your any one logical view of for plain text or key. Key also taking the 128 bit, so it is also represented 16 bytes பண்ண போறோம். So 16 bytes naka, how to arranging our logical view of the plain text naka, 4 rows and 4 columns. So a matrix representation is used to view the logical view of the plain text or key. So each and every byte, totally 16 byte. So one part, one pixel is here we can represent it or as a 1 byte. So totally 16 byte. So 16 byte mean it can be occupied 128 bit. So this particular data structure normally used in the operation of AES. Okay. So the number of round in AES is variable. It is depending upon the length of the key. Where you can say, for example, in AES use the turn round for 128 bit keys. Suppose you can using the key size 128 bit naka, you can using the 10 rounds. 192 bit key take the 12 rounds, and 256 bit key use the 14 round. So normally we use the 128 bit 10 round and 128 bit plain text. Okay. So another one representation, normally byte to byte only we represent your data. Data means what the input text. Okay. So that is a 128 bit. Next one is a key, also 128 bit. That particular key is normally expanded in the array format. Expand the array of 44 32 bit words. It is represented by the W of I. Okay. 4 distinctive word 128 bit serve as a round key for each round. So each round normally we can using the some key, because in each round we can give the plain text. We can take the plain text of 128 bit and key of 128 bit, then perform some operation. Okay. So that time one more changes in the AES is here. Here you can using the 44 array of words. What is word? Word is nothing but it will be take one column. That means word is nothing but we take, for example, yes. So one word is represented this particular part in the key. Now this is a logical view of the key means, so one column. So totally 16 byte here occupy 4 into 4 matrix, 16 byte occupying, 16 byte key occupying. So but it was expanded as a 44 words. So each word how we can represent, normally key on the 16 into 6 da irukum, but how to represent data structure representation of key naka, here now we can discuss the key. Okay. So 44 words are no. What is 44 words? So 44 words now, one word represent one column. That means the 4, this part, this part, this part, this part. Okay. These one single column of is represented by one word. Similar like that, if we take the 16 byte key to expanded into 44 words. Normally initially we can take it only the 16 byte, now we can take it as a input of the key, but we can using the 44 words. one word only take the one row. So maximum here only possibility of the four columns. So then how we can extend next to 40? So we can extend that using some extended procedure, extended key procedure. We extend this particular 16 byte key to represent into 44 words. In the 44 word array of word will be take it as a input. I can give it to the all the 10 rounds. Try to understand. Okay. Read it. These are all only the data structure representation. How the plain text data represented in the AES, how the key is represented in the AES, then how it was extended. And it is a one single key. The same key we can use it in the all the round naka. It is easily breakable one. So we expanded the key, then give it to the input of the each and every round. Okay. Next, this is a summary of entire operation of your AES. This particular abstract we discuss in the end of the section. Okay. So now we can see this diagram. So this diagram normally represent a input and output array or matrix representation. Okay, of any input or output. What is the input? Input means the plain text. Output means ciphertext. So input represented the 16 byte into 4 into 4 matrix format. Output also, that means ciphertext also represented in the same. You know it very well. DES, what happens in the DES? I can give the 64-bit naka. You can divide it into 2 of 32-bit, 32-bit. Then finally we can do some performation to do some round operation. Finally we can get the output of 64-bit ciphertext. Purida. Similar like that, here the data structure of the AES is a 16 byte, 128 bit. So it can be represented as 16 byte. 16 byte, how we can represent naka? It will be take it in the 4 into 4 matrix. So this is your input plain text representation. This is your output representation. But in between, we do some 10 round operation. You know it very well. In the round operation, we can using substitution and a permutation technique. We use it. So each and every round operation, we can get one intermediate output. Intermediate output that is called as a state array. Okay. That 16 byte state array. If first round completed, we can get the first state array. Second round completed, second state array. This is intermediate result of the or intermediate ciphertext. Okay. So this is a part of input. The next you can come into the part of key, 128-bit key. Here we represented as a 44 words. That particular 44 words we use it in the algorithm, encryption algorithm of AES. So you can K0, you can here see the diagram, K0, K1, K2, K3. This first column we represented as a word 0. So array representation of word normally you know it very well. 0 to n minus 1. So 0 to 43. So first column represented first word, second column represented second word, third column represented third word, fourth column represented fourth word. But after that, we can also take it up to 44 words. So normally this particular given input key is expanded. It is a separate, very big procedure is there. Now you can see this diagram, how the each and every column represents as a word. So normally here we can take it the 44 words, we can take it to give the input of the each and every round operation. First 4 byte enna pannirukkom. First 4 word we can give to the first round operation input kodukano. Second 4 word we can give to the input of the second round operation. Similarly like that 10. So total 10 into 4, 40 word is there. Another one additional in initial round we can take it as a 4 additional key to give it input as a input to the particular round operation. Okay, that's why additionally we need the 4 words. Okay, actually this what your AES key expansion, actually it is a separate procedure. Okay, so this is here again how the AES key expansion will be done. It is a separate procedures. It is a separate algorithm also. Okay, but here you just to know it, take the 128 bit, that means 16 byte, then we can, that means 4 word, we can take it, then it was expanded into array of 44 32 bit word. So this is a procedure for AES key expansion. In this AES key expansion, from the 16 byte, we can take it as a each and every 4 byte as a 44. So 4 word, then we can take it into 44 words to expand it with 44 words. Okay. So this is used in our encryption of AES algorithm. Now, so next we can come to the part of round operation. So what happens in the each and every stage, or what happens in the each and every round? So normally we use the some combination of permutation and substitution operation. So as per the AES algorithm, we use one permutation and 3 substitution. So each and every single round operation, we use the one permutation and 3 substitution. First you can see the diagram, then come to this particular part. So this what your overall structure of your AES algorithm. So normally, so in the each and every stage we use one permutation, 3 substitution. Okay. So here we can take it as a 4 operation here we can perform. So first one is a substitute byte, S bytes. Substitute byte is nothing but you use the S box to perform a byte to byte substitution of the block. We can take one block na another 128 bit na represent panna porom 16 bytes rows and column, row 4 column na 16 byte represent panna porom. So that 16 byte to perform with the Xbox operation to get one intermediate value. Next, on the intermediate value, we can give it as the shift row operation. We can give it as the input. Okay, wow. So next operation, shift row operation, it is nothing but it is a simple permutation operation. Simple permutation operation. How to do the permutation? Rearranging the element. Then we can get one intermediate output. 16 bytes of intermediate output. That we can give it to the mixed column. What is the mixed column? Mixed columns is nothing but a substitution. It's a substitution method because you know it very well. Here each and every stage we use here one permutation and 3 substitution here. Okay. So mixed column is a substitution that make use of arithmetic of that means finite numbers. GF of exponential 2 power 8 arithmetic model we can use it for to substitute your values. That is a mixed column. We briefly discuss in the next level. Okay. Next one is a add round key. So in the add round key part only, we XRO with the, that means byte here we can using the byte wise XRO. Okay. Here we can using the byte wise XRO. That means whatever data, that means 16 byte data come from the mixed column, output of the mixed column, then that value we can take it. Then 16 byte of or 4 words. Okay, we can take it from the key. So both are XOR. That means the bitwise XOR will be performed. Okay, so this operation is called as a add round key. So as per the AES, each and every single round we performing with the 4 operation. Okay. So first one is a substitute byte. You clearly understand the terms of each and every operations. Substitute byte, shift row, mixed column, and add round key. Okay. So what are the stages in cipher means? You can understand this particular point once again. Initial round only add round key stage. Initial round means first part of that particular operation, it will be take only the add round key stage. Next we followed by the 9 rounds of each one include the 4 stage. Yeah. So next 9 rounds we can take it all the 4 stages. That means 4 operations. Then 10th round we can use only the 3 stages only. We are not using the 10th stage. We are not using the mixed column. Okay. These are the normal procedures. You remember it. Okay, so initial round with the odd round key stage, then it will followed by the 9 round of each one include of 4 stages. That means the remaining 9 rounds all are take the all the 4 stages. All the 4 stages means the 4 operations: substitute byte, shift row, mix column, and add round key. Okay. So this is what your overall structure. So you can see the diagram in the plain text 128 bit. That means it can be referred by the 128 bit, or we can take it the 4 into 4 matrix of 16 byte representation. Okay, that's the structure of data, plain text data structure. Then key also similar like that we are using. Okay, in the initially what we can do it, we can take the add round key function in the first stage. After that 9 rounds, up to 9 round we can using the 4 stage of operation. That means S byte, shift row, mix column, and add round key. Then in the 10th round, we can using one of the 3 stages. That means substitute byte, shift row, add round key. We are not using mix column here. Finally, we can get the ciphertext of 16 byte or 128 bit. Okay, how we can using the key? So normally key, you know it very well, 128 bit. So 128 bit, normally we can take it as a column. Each and every column represents as a bird, one bird. Okay, so initially first we can take it the 0 to 3 bird to give it as an input of the first add round. After that 9 round is there, all the 9 rounds. So remaining all the 9 rounds, remaining 4 byte, next 4 byte, 4 to 7, next on the 8 to 12, like that. We can give it as a 4 byte to give it as an input of the add round key in the each and every round. So finally in the 10th round we can using only the 3 stages. In the 3 stages we can also using add round key. In that key we can use it as a bird of 40 to 43. That means that particular 4 bird can use it as a input to give it to the add round key function along with the input value come from the shift row. So now we can take this is a 40 plus 4, totally 44 birds. That means the expanded key birds are used in the add round key function. This is what your encryption operation. Frida. So next we can go for the decryption. So decryption, we can take the 16 byte. Whatever I'm saying bytes only, because we represent the input or key data only referred by the bytes. Okay, va? அப்போ இன்புட்டை நான் பைட்ஸாக ரெஃபர் பண்ணுறேன், 16 பைட்டாக ரெஃபர் பண்ணியிருக்கேன், ரெப்ரசன்ட் பண்ணியிருக்கேன் டேட்டா ஸ்ட்ரக்சராக. கீயை வந்து எப்படி பண்ணியிருக்கேன், 4 byte, ஓகேவா, 4 byte வேர்டாக ரெப்ரசன்ட் பண்ணியிருக்கேன். ஓகே, ஸோ அகைன் இந்த ரிவர்ஸ் ஆப்ரேஷன் round 1 to round 9. ஸோ round 10ல we can using the 3 stages. Initially we can take the round key function 1 stage. After round 1 to round 9, 4 stage operation performed in the reverse side. The finally round 10 is a 3 stage operation. So this particular decryption process, you know it very well as per the diagram. It is a reverse process of the encryption. Prida, once you can understand this particular diagram, you can clearly what operation is performed in the AES. Okay. This what another one encryption process representation, stage by stage. For example, 16 byte, we can take it. So 16 byte is array representation. Initial array வந்து நம்ம என்ன பண்ணுங்க, matrix represent பண்ண போறோம். So matrix represent பண்ணிட்டு initial transformation, that means substitute பண்ண போறோம். Okay, after that we can get one intermediate result. அதுக்கப்புறம் round function I can give it all the 4 transformation, 4 stage of operation perform பண்ண போறோம். Again we can get one output, intermediate output, that will be given to the input of the next round. Similar like that, each and every level of round we can get some intermediate output. After completing all the turn rounds, we can get the final ciphertext. So this part is called as a key generation part. You know it very well how it was represented as a bird, and each and every 4 bird give to the each and every round key functions. Prida? Up to this part you can understand. Then you can go to the each and every stage operation, how it was performed. Up to this level, or understand? Hello? Up to this level, or you understand? Try to remember all the stages, okay, the 4 stages, as well as how it was situated. Because in the add round key, initially separately that stage operation will be performed. After that 9 rounds, we perform the 4 stages of operation. That means substitute byte, shift row, mix column, and add round key. In the 10th round, we can take only the 3 stages. Substitute byte mattum pannuvom, shift row, and then add round key only performed. Then finally get the ciphertext. Decryption, again it was in the reverse side operation. First add round key, but the key another key also in the reverse process decryption. Okay, again 9 rounds 4 stages of operation perform பண்ணுவோம். 10th round 3 stages of operation perform பண்ண போறோம். Finally we can get the plain text. Okay, so this what. Next we briefly discuss about what happens in the each and every stage. Okay, first we can take the byte substitution or substitution byte, sub bytes. So this what similar to your DES. In DES we can take the 56-bit 48-bit key. What happened in the DES, you remember? You have any idea? The substitute byte operation, what we done it in the DES algorithm. We can get the input of 48-bit plain text. Okay, totally 8 Xboxes we use it. So 6 into 8, each and every Xboxes give the input of 6-bit. Because 6 into 8, 48-bit total. Okay, then we can get the output of each and every Xboxes give the 4-bit. So 4 into 8 Xboxes naka 32-bit output. This what happens in the DES algorithm. So what happens in the AES algorithm? Here we can take it the 16 byte. Here represent as a byte, but 16 byte. The 16 byte, for example, I can take this part only, S comma 1 comma 1. In this particular part, you can have one data. Okay, data representation. Suppose we can take it 1 0 1 0 1 0 1. Some representation is there. Okay. So normally how to represent here, you can check it with the Xbox. Xbox is here another one data structures represented by the 16 into 16 column. Okay. So normally first bit and then input of the first bit and first column and then last bit column. Take it as here represent as a row panna porom. Remaining intermediate vara yellow byte ena panna porom. Column represent panna porom. So X represent row and Y represent column naka. So automatically we can get this value. For example, this is it can have one value is there. In the Xboxes, one value is there. This data value I can substitute in the output matrix. In the output matrix, one of the intermediate matrix, intermediate value. No, it's not a final ciphertext because then we can do the 10 round of operation, then only get the ciphertext. This is one of the intermediate output. In the especially from the substitution bytes. So here I can take it to represent a row and column. The row and column reflect pandamari, you can get one value. What value here, that value we can represent it in the intermediate output la adhe position la we can fix it. For example, inge or value 2 value okay. 2 value some we can represent it in the 8-bit representation la pannirkom. So depending upon the value we can X and Y row and column represent pannite, we can get here you can 4 and for example. So this 4 the 2 ku badala enna panna porom in the 4 value eduthu intermediate matrix la adhe position la fix panna porom. Appo normally it was substituted, 2 will be substituted by 4. So that means 4 is substituted from the 2. Okay, using some Xbox operation. This is called a substitution byte. Prida. It was similar to the DES, but only one thing, here you can use it the 4 into 4 byte operation, matrix format you can use it, that's all. But methodology will be same. Next one is a shift row. Shift row, you know it very well, it is a permutation operation. Okay. So in this permutation operation, so this is our input matrix. Okay. Input matrix naka. So previously we can, after completing the byte substitution, we can get one intermediate matrix. This intermediate matrix I can give to the input of the shift row. Okay. So then first row I am not changing anything. So you can take the first row, I am not changing anything. Okay. But I can take the second row, shifted 1 byte position to the left. Second row வந்து 1 byte என்ன பண்ணுது, left shift circle shift பண்ண போறேன். Okay. Then second row I can take the third row 2 position left circle shift பண்ண போறேன். In the fourth row I can take it into 3 position left circle shift operation perform பண்ண போறேன். Okay. So rearranging the element using the single or 2 or 3 position left circle shift. Done it. After completing this one, I can get one intermediate result of this array. I can give this array, I can give it as a input of the next stage. So next stage is the mixed column. So mixed column is nothing but it is using some mathematical function. That is GF 2 power 8. Okay, wow. Exponential finite number operation perform on a. So how we can do it means, normally I can take the input, whatever data matrix come from the previous stage, then multiplied with the 2 power 8 matrix calculation, mathematical function. That function order multiple panni, we can get one value. So that value is the output of the mixed column. So here we can using one complex mathematical function to multiplied with the input matrix, then get one intermediate output matrix. Okay. So that was written in the mixed column. Next one is here add round key. So add round key, normally add round key means then here only we can use the key. That means we can get the value from the mixed column, one output, intermediate output of the 4 into 4 matrix. So on the data value enna panna poren, XRO with bitwise XRO with 128 bit keys. 128 bit key eppadi represent pannirpan nanu 4 words ah represent pannirpan. You know it, you remember it. So on the 4 words I can give to say input கொடுத்துட்டு, so plain text 128 bit, okay, key value வந்து 4 words represent the 128 bit, then we can perform the add round operation of add round operation nothing but என்னது bitwise XOR perform பண்ண போறோம், அவ்வளவுதான். Okay, so next we can get one output. Okay, that output we can give it to the, that output we can give it to the next round operation. இது வந்து first round operation எடுத்தோம். For example, as per see the diagram, the particular figure. So substitute byte, shift row, mixed column, add round key complete பண்ணதுக்கு அப்புறம் we can get one 4 into 4 matrix. Okay, output matrix. And the output இது வந்து it's not a permanent output, it is a temporary, that means intermediate output. So that will be given to the next round. Similar like that 4 round I can give it, the 10 round completed, then only I can get the original cipher text block. In the as per in the cipher key, the 4 into 4 byte key expanded by the 10 number of times. Okay, this is what your overall operation performed in the each and every stage. What happened in the substitute byte, what happened in the shift row, mixed column and add round. Okay, this is your overall structure. This is another one representation. For example, the stage 1, okay, 4 bytes எடுத்துக்குமா. Okay, so total 128 bit 16 bytes. So that means you can take the substitution of byte. X box எதனை யூஸ் பண்றோம், we can take it the 16 X boxes, we can get intermediate in the stage எல்லாமே intermediate results. That it can have a 128 bit, that mean என்னது 16 bytes தான் இதுவும் இருக்கும். Okay, so 128 bit, again it will be given to the input of the shift row, we can get some intermediate result of stage, next stage. Again we can get perform with the mixed column operation, we can get some intermediate output. Finally I can using the words, 4 words to give the input of the add round key along with the previous plaintext value. Then finally we can get the actual ciphertext of 128 bit or 16 bytes. Or understand? So this is what your AES encryption operation. So decryption operation, you know it very well, reverse process. So normally it will be take in the actual the 4 rounds of operations in the reverse order. இது வரைக்கும் புரியுதா? This is what your AES operation. This is here one of the analysis of your AES. Normally the request versus user load of the AES general, it will be very high. Comparatively, response time is very less. Normally you need more number of requests is required. Similarly, Reginidol to give the result of more number of requests, depending on load increase on whatever it will be, it can be more number of requests will be made it. Similarly, the more number of load, user load will be increasing, but response time is very less. That's why it is a very efficient computation algorithm. Okay. Then just we discuss what is the difference between the AES and DES. Okay. AES standard, advanced encryption standard. What is DES? Data encryption standard. Okay, what is the key length used? 128 bit. Depending upon the round, it will be different. Okay, but 10 rounds na 128 bit, 12 rounds na 192 bit, 14 rounds na 156 bits we are using. Okay, in the AES algorithm. So what happens to the DES? DES normally key length on the 64 bit, and the 64 normally we can use it only the 56 bit key. Okay. In the number of round, how many number of round we are used in the AES? Normally we using the 10 rounds. In the DES, 16 round we use it. Okay. Another one thing, what is the structure we can use it in the AES algorithm? Here you can use in the SP standard network structure or iterative structure. Here you can use it. But in the DES algorithm, we can using the physical network structure. Okay. Then comparing with the DES, AES is more secure because of the key bit, more 128 bit keys we are using. Okay. But comparing with AES, DES is less secure. Okay. So in the round function, what are the permutation and substitution operation use? It means 1 permutation and 3 substitution we can use it in the AES. That means byte substitution, row shift only is called as a permutation operation. Matta mono substitution operation. Okay, in the DES we can take it as a XOR operation performed with the round key, as well as some substitution and permutation operation are used. Prida. So this is what were difference between AES and DES. Sometimes the question will be asking in the part B, one part of the 5 mark or 6 mark question will be asking in the university examination. So be thorough with it. Okay. Understand? So this is what your AES algorithm, advanced encryption standard. Actually, this was used nowadays in all the application, whatever in the smartphones or ATM machines or web, everything. Okay. So next we give some introduction about the primality test. So already I have posted in the primality testing methods. Okay, the primality testing method is nothing but normally we can check the given number is prime or not, or given number is a prime. If it is a small number, we can easily find out. But if we can take the large number, because in the cryptographic, normally you can using the random number generation. We can use the prime number. You can use it as a random number generators. At the time of key generation, what you can do it, we take some random keys that variables or that number. We can use it as a prime number. But only one thing, you can take any number. How you can check it that particular number is prime or not? That is called as a primality test. Okay. Normally we can using the 3 method. One method is a normal basic method, or whatever you can school days you can using. That means a simple solution is to iterate through all the 2 to n minus 1. Suppose we can take the n number means you can divide it by each and every number divided by n. Okay. So finally I can get 1 and itself number only properly divide naka. That is a prime number. Suppose any other number divides that particular number naka, automatically it is a false. So it is not a prime number. That means it's a composite number. Okay, in that way we can school level or the smaller number of numbers we can to find out it's a prime or not. Okay. Another method also we can use it. Another one method is a Fermat-Little theorem. Okay, Fermat-Little theorem means this is a Fermat theorem. That means a power p minus 1 congruent to 1 mod p. So using this theorem also, that means the p is not divisible by a. So automatically we can get the remainder of 1 naka that p is that prime number, that p value is called as a prime number. Otherwise it is a composite number. But what is the problem in the Fermat-Little theorem means, suppose you can take some composite number to give it in the Fermat theorem algorithm. Okay, well, it will be give some wrong result. For example, you can give to the prime number, you can take any one prime number to apply the Fermat-Little theorem. So it will be give the correct answer. Sometime you can give it, given the number is a composite number, but it will not give the correct result. It is a drawback of the Fermat-Little theorem or Fermat theorem. Okay. So to overcome this particular problem, normally, so 99.9% accurate result we can get it. What the result means here? That means the given number is prime or not. Normally we can find out the given number is prime. Okay, so the Miller-Robin algorithm used to find out a accurate result. That means 99.9% accurate result we can get it from the Miller-Robin algorithm to get your given number is prime or not. Another one important things, actually the previous method all are used only the small size of number, prime numbers only applicable. But in the Miller-Robin algorithm, we can use it the large size of prime number testing is possible. So already I posted the 3 videos in your Google Classroom with along with examples. So okay, you can go and see this particular videos to get more understanding. It's very interesting thing one. Okay, please either. Or understand what is the primality test, what is the Miller-Robin. So it can have a 3 method. One is a normal division method, another one is a using the Fermat-Little theorem to find out your prime or not. Final is a Miller-Robin method. Okay, or understand? Breathe Durigam. Okay. The representation or data structure representation of AES is a very important thing. So you once again learn carefully. That way, that make little bit confusion to you. So once you can understand what, how the data, that means the input plain text and the key represented in the AES algorithm, then remaining things are very easy one.